the last examples we did were the equations were written in terms of time. Okay, so our inputs were time. These next two we're going to look at when the input is theta. So using trig, your favorite. So we eliminate the third variable a little bit different when we have trig in our equations. So it's easier for us, instead of just solving for theta, is to solve for cosine and sine. And this is why. So I remember in a rectangular equation, that x squared plus y squared is equal to 1. Remember, that's like your good old unit circle. Okay? So if I choose a point on my unit circle, remember, the y is equal to the sine of theta, the x is equal to the cosine of theta, and the radius is equal to 1. And this is an identity. It's true for all angles. So I can rewrite this as cosine squared theta plus sine squared theta is equal to 1. So when I want to switch to get back into terms of rectangular equations, what I want to do is solve for cosine theta and solve for sine theta so that I can plug those in to get my x and my y's. So 1. So we're going to call this parametric, trig parametric to rectangular. So eliminating the trig variable. Solve equations for sine theta and cosine theta, respectively. 2. Substitute into, we're going to substitute that into cosine squared theta plus sine squared theta is equal to 1. Okay, so we have our two equations here. Let's start with the top. X is equal to 3 cosine theta. We're going to divide by 3 because 3 is on the outside. I can do that. Cosine theta is equal to x over 3. All right. And then for the y's, 4 sine theta. Again, 4 is on the outside. It's not on the inside here, so we can divide. So sine theta is equal to y over 4. So in step number 2, we're going to start with our identity. I know that cosine theta plus sine theta, this is always true, is equal to 1. So I have a value for cosine theta and I have a value for sine theta. So I just need to substitute those in. X over 3 squared plus y minus 4 squared is equal to 1. You guys don't know what kind of shape this is, I don't think, but it kind of looks like a circle and the stretch values are different. So this is an ellipse. We're going to study those after matrices, okay? So you don't have to graph those. No graphy, okay? B. So this parametric equation has sine and cosine in it. So we're going to solve for 2 plus 3 cosine theta. We're going to get cosine theta by itself. So minus 2. X minus 2 is equal to 3 cosine theta. Divide by 3. Cosine theta is equal to x minus 2 over 3. And then again for y. So y plus 1 is equal to 4 sine theta. Divide by 4. So sine theta is equal to y plus 1 over 4. 2. Sub this in for cosine squared theta plus sine squared theta is equal to 1. So I get x minus 2 over 3 squared plus y plus 1 over 4 squared is equal to 1. Again, you don't know what type of shape this is, but the stretch values are different. It's kind of like a circle, but the stretch values are different, so this is an ellipse. Don't worry about that until chapter 9. Okay? That's it.